All right. So yesterday we were talking about, and the last number of days, volumes by slicing. Now, there are two types of volume problems that can work for slicing. The first two we dealt with were solids of revolution. Now today, we're going to do an alternate method of finding solids of revolution instead of by slicing. And I told you that's by, we call it by wrapping or by layers. So we'll have an alternate form of those first two, the disc and the washer. Okay, it's called the shell method. We're going to talk about that. Now, why would we have an alternate method? Well, there's some times where the shell method is easier than the disc or washer. So it's a nice alternative. Plus, it allows you to see how we can use the integral in a different way to come up with that same result. The new things we learned yesterday, there's really no alternate form of those. Those are slicing problems no matter how you slice it. I kind of stumbled into that one. On 3, 4, and 5, you're given a region that is the base of the solid, and you've got these slices rising up off of the base that creates the solid. So the integral to add up the slices, that's really the only way to do those. Okay? So that's our 1 day of practice on those. The strip, of course, is the key. The strip is either a radius or a diameter or a side of a triangle, side of a square, area of the slice. Okay, so it sounds like everybody was doing a pretty good job on those. Okay, yesterday we did the sample 4. We kind of went through some of the problems or questions you might have had in the first part of that packet. Friday will be kind of another packet day. We'll be working on the rest of sample 4, probably get into some of the free response as well. Is there any, before we go on to the new thing today, is there anything that you want to see on yesterday's stuff? Or anything we didn't get to in that sample pack? Okay. All right. Well, here's what we're going to do. I want to start you with this problem. Okay. So let's move to a new page here. Hopefully this is working. Okay, I want you to take this region. Just go ahead and work this in your notes here. Okay. Okay, take that region and draw a picture and the region bounded by the first line here, and then revolve it about x equals 5. Okay? Go ahead and work on that. Okay, are you noticing any difficulty about this one? I don't know if difficulty is the right word, but anything special you have to do? Is this a disc or a washer? Which way are the which way are the strips? Okay, what else? You have to do it in two separate pieces, don't you? Yes, you do. Okay, go ahead and do it. Would anybody like to discuss that further? Why you have to do it in two separate pieces? Okay. All right, go ahead and set it up and see what you get. All right, if you're working along on that, go ahead and keep going here. Okay, so the red line there is going to divide that up into two pieces because the horizontal strips will touch the curve in different places below the red line compared to above the red line. And this is a washer because there's this empty space. Now you could argue that the empty space is the shape of what? It's a cylinder. So a person could look at this and just do it as a regular disc problem and then just do the cylinder and subtract it out. And I mean, that's fine, but we know in some washer problems the empty space is not just a cylinder. So we usually do it as, as a washer. So I'm going to set it up that way. So above the red line, since it's a washer, I've got an outer radius. What would be the outer radius here? What'd you write for that? No. It's this x coordinate minus this x coordinate. So what do we got? 5 minus y squared. This is the curve x. Okay, now this is supposed to be the easy part today. So I'm a little nervous about where we're at right now. Unless we're just being really quiet. Okay, maybe that's it. Okay, because this is supposed to be the easy part, right? I mean, we got that quiz next Wednesday, and there'll be all these different things under. Okay, outer radius is 5 minus y squared. And I guess I thought this was easy stuff because I've been really lonely, fourth block. I have all my usual people come in and get help I haven't seen. So I'm assuming we're doing pretty good on this. 5 minus y squared would be the outer radius. What about the inner radius? 5 minus 4, which I'll just write 5 minus 4, but that would be 1. So our formula for a washer is pi times big R squared minus little r squared, correct? And it goes from what to what? The strips fill the space from 1. This would be the 0.42 up here. So from 1 to 2. Okay, the bottom section, big R is now the bottom, again, the bottom section is just a cylinder with another smaller cylinder out of it, right? So you wouldn't even need an integral to do this one. But, I mean, usually you're on kind of a roll doing the integrals, and so you typically tend to just go ahead and do it anyway. I think it can be more confusing trying to figure out the cylinder than just doing this. Whoops. 5 minus 1, and little r is 5 minus 4. So your integral is with a pi, and then it would be 4 squared, and then minus 1 squared dy. And it goes from 0 to 1. Correct? And we would add those together. Get your calculators out and do that. Now that wasn't an easy problem in the sense you did have to split it into 2, and you got to remember the washer stuff, and it's been a few days. Okay, I get that. Anybody getting an answer there? Yeah, whole thing.
Like 36, 572.
Okay. That could be. I don't know. In terms of pi, was there, or did it come out in terms of pi?
328 pi over 15. Yeah.
Is that the same decimal as what you've got, Jacob? 328 pi over 15?
No.
68.696.
How much is it?
68.696.
Okay, well, let's double check each other here. Because we're going to do it an alternate way here later. And I want to compare answers. Did we make any mistakes along the way there? Does everything look good? Okay, so both of them added together. Both. Are we getting this?
Yeah, I know.
328 pi over. Okay, so now, if thinking about our quiz, thinking about the quiz next week, when we started out doing this, when we started out in this chapter, we just started out with area of regions. So if I ask you to just find the area of that region that we just had up here, from 1 to 4, we talked about how you could find that area using either vertical or horizontal strips. Now you had your choice in those problems. Now sometimes there were a couple of homework problems where they said use it in terms of y, and some said use it in terms of x, and so. But on the quiz you have your choice. So if I gave you this region, so find the area of it, what direction would your strips go? You would probably choose vertical. If you want to do horizontal, then you'd have to split it into two pieces like we just said. Now, just so you remember, the way we did that is we just then did, that would just be the integral from 1 to 4, this y-coordinate, square root of x, minus this y-coordinate, 0. I mean, that would be it, right? Because what the integral did was add up all of the strips. You know, we've been doing all this talk about adding up slices. Okay? Here the integral is just adding up the area of all the strips. You got the height of the strip, you got the width of the strip, that's the area of the strip. The integral adds up the strip. So we had a choice. We could do horizontal or vertical strips. But with this, oops. With this problem, we did not have a choice to do vertical strips, right? I said do the volume of this region. The axis was x equals 5. So what we learned about slices is if the axis of revolution is here, the slices have to be perpendicular to that. Just like this lemon, if we had it up and down so that we had a vertical axis of revolution, we'd have to do our slices this way. Okay? We laid the lemon this way, so we did the slices like this. Okay? So we don't have a choice. And unfortunately, it allows us to do this. Well, that's our alternate method we're going to learn today, gives us that choice. Our alternate method is we're going to be able to find this same region, the same volume, with vertical strips. Okay? Now here's how that's going to work. If I have, imagine here you've got the lemon sitting here like this. Okay? If we're going to slice that lemon, then the rectangles have to lay that way. Okay? And so when we look at a slice, depending if there's empty space or not, we either have a disc or a washer. And then the integral is going to add up all those slices. Well, what we're going to do instead is we're going to take that lemon and we're going to look at its layers. In other words, if we could take a peeler and peel off a layer of this and set it down, it would look kind of like a cylinder. And then we could take another layer and another layer and another layer and another layer until we took the whole lemon. That's what we'd be talking about doing. Now, this is called the shell method. So they think of those as shells, right? Layers, I think, is a better term, but shells is the term we're going to use because that's what all the books use and everything. But if I do that, notice how the rectangle here is the opposite orientation of this one. Here we got a horizontal one to create the slice. Okay? So if we're doing a slicing situation, we always slice perpendicular to the axis of revolution. But what we're saying with our layer thing is we're going to do it like this. Okay? We're going to wrap around the axis of revolution. The rectangle, the strip, is going to create the layer. So it'll look like this when we revolve it. Okay? So what that's going to allow us to do is if we've got a volume of a solid of revolution and we don't like horizontal strips, they're going to be trickier to do, we can do this method and that will turn our strips the other way. Make it easier to do. Okay? This would be just one layer. Just like this is one slice. So we will find the volume of this one layer and then we'll let the integral add up all the layers. Okay? So our job is to find the volume of this layer. Now it's got a certain thickness, just like this slice has a certain thickness, but when we do the integral, what happens to that thickness? Infinitely small. So we're going to do the same thing with this cylindrical shape. We're going to do the volume of this solid piece, the blue ring piece, but we're going to let that get smaller and smaller and smaller. Okay, so if I can stop this red one here. Okay, so let me write over top of this. So we are going to, and this is what we're going to get for our new formula here today. We're going to develop this. It's not something you're going to have to ever copy down. You only really need the final formula, so if you don't want to write it, that's fine. But I'm going to label some things here. Now, normally, what is the volume of this cylinder right here? What would be the volume of a cylinder like this with this hole in it? Now, I'm talking about the volume of the solid piece, the blue piece. How would you do that? What's the volume of a cylinder? Pi r squared h. So how would I find the volume of this solid cylindrical shape? Outer cylinder minus inner cylinder, right? So what I need to do is I need to do that. Now, when this blue, when that red rectangle gets thinner and thinner and thinner, all of a sudden there becomes no difference between big R and little r. So I'm going to have to relabel these a little bit to make this work. So here's what I'm going to do. I'm going to call P this distance from the center to the middle of that strip right there. I'm going to label that P. Okay, that's from the center out to the middle of the strip. I'm going to call W the width of the strip. And we're going to call H the height of the rectangle. Okay? Now, in my formula up here, and we'll go to another sheet here in a minute, but I'm going to substitute out R. What would be another name for the outer radius using the letters I've got here? P plus 1/2 W, right? P takes me to the center of the strip, and then half a width to the outer radius. And then little r would be squared. P minus 1/2 W squared, like this, right? Yeah, what the heck, I can write right on this. So now I'm going to work this. Now this is a volume of just this one layer. Then of course the integral is going to add up all the layers for us. Okay, so let me FOIL this out. Let me factor out a pi and an h. And then let me FOIL the rest of this out. So this would be what if I FOILed it out? P squared be 1/2 PW plus 1/2 PW. That'd just be PW plus 1/4 W squared. And then I've got a minus, so I got to be careful here. I got a minus. Now I'm going to FOIL that. P squared. That would be minus PW, but it turned to a plus. And then this would be, well, it'd be positive 1/4 W squared, and then I'd have to minus it, right? So minus 1/4 W squared. All right, what happens? P squareds cancel. 1/4 W squareds cancel. 2 PW left. So I end up with 2 pi P H W, right? That's the volume of that blue cylindrical layer. Now, as that layer gets thinner and thinner and thinner, what happens to W? That turns into the dx. dW, okay? That's going to go away as we do the limit with a sigma, right? As W approaches 0, that's essentially what would happen. So what we're going to end up with is the integral of 2 pi P of x, H of x, because they're both going to be changing amounts. Each layer is going to have a different P value and a different H value, and then the W just turns into the dx. All right? So let's write that in our notes here. Okay? So volume by shells or layers okay, is going to be the integral from A to B. We'll pull the 2 pi out in front. P of x, h of x, dx. Now, of course, the difficulty then is what is P and what is H in each of the problems. Now, H is easy. H is the same thing as it's always been. It's the length of the strip. So that's top minus bottom, right minus left. Now again, the only reason we do top minus bottom, right minus left is so we get a positive value, right? Bigger number minus a smaller number. And P is the distance from center to the strip. Now that's going to be the one that some of you will have some difficulty understanding right in the early stages, and eventually, hopefully, we'll come to get that. But it's the distance the strip is from the center. That's a new measurement that we haven't ever done before. Okay? All right, but again, you can see where that came from because we got that formula from the layer, from that one cylindrical layer. A lot of times it's called the method of cylindrical shells. It's a cylindrical layer because, again, we're revolving the solid, so that's why it's a cylinder shape. All right, so let's do this problem we just did a minute ago by this method. All right. Oops. Probably undoing that previous page. Yep. There we go. All right. Well, that blue thing's not supposed to be there. All right, so let's go ahead. Oh, that's not right either. There it is. Okay, so go ahead and draw this region that we just did together a minute ago. All right, same exact problem. We've got this blue region. We're going to revolve it about the line x equals 5. Okay? But this time we're going to choose the shell method. Now this is where we get this option, now that we learned this method, because we've got a vertical axis of revolution, x equals 5. You're being asked to revolve that region, so one way of looking at it is the way we looked at it earlier today. Okay, we're going to take and revolve this. Okay, it's going to be a horizontal strip. It's going to be a slicing. They're going to be washer slices because there's empty space in there. And then, of course, we had the difficulty of we had to split it into 2 regions. So that alone is enough for you to say, hey, I'd rather do the other method. Because if I've got the axis revolution, x equals 5, I can wrap using the shell method and give myself a vertical strip. So we draw in the vertical strip. And this is going to make this problem much nicer. We don't have to split it into 2 pieces. Not only that, but with the shell method, you don't have to worry about the empty space. Why won't we have to worry about the empty space? Because it'll only wrap, where the solid space is. The integral will only go from where to where? 1 to 4. So that empty space from 4 to 5 is just taken care of in there. So we don't even have to worry about that. So what we need is We need what P of x is, and we need what H of x is. Now, H of x is an easy one to do first because we're used to that. H of x, again, go over to your notes here. H of x is just the length of the strip. Well, the length of the strip is this y coordinate here, which is square root of x, minus this y coordinate, which is 0. So that's H of x, that's easy. But what is P of x? P of x is the distance from the center, which is your axis of revolution. Maybe we probably should write that instead of center. We should write the distance from the axis of revolution to the strip. How far is it from the axis of revolution to the strip? Now remember, the strip could be here, or it could be here, or it could, you know what I mean? Daniel says 5 minus x. I like that. It doesn't the strip have an x position? The strip's either here at an x coordinate of 1, or it's at 1.2, or it's at, right? And if the strip was here at 1.2, how far is it away from the axis? 5. 5 minus 1.2, right? So the distance from, now a lot of times I write a little thing here. A lot of times I'll just label my strip as x, and I'll draw myself a little line here, and I'll think of this as a right minus left. Because really all right minus left means just take a bigger number minus a smaller number. How far is it from here to here? Well, it's this x coordinate 5 minus this x coordinate of the strip, which is just x. We don't know what it is. It could be any of those x coordinates in there. So that's exactly right. This P is 5 minus x. Now, little something to remember about P. It will always look like that. It will never have square root of x in it, or x squared, or sine x. It'll never have that. It'll only be 5 minus x minus 2. I mean, depending whether the strip is on which side of the axis of revolution, might be 5 minus x or might be x minus 5. You know, if our region was on the other side of the 5, it'd be x minus 5. Right? And we might get horizontal strips. See, we can do shell method with a horizontal axis of revolution, and we can wrap this way instead of slicing this way. Right? We can wrap this way. Now, why would you want to? Well, maybe the horizontal strips are easy to do, and you just like shell method better. Matter of fact, I wouldn't doubt on the quiz, some of you will probably, if I give you a problem, just say find the volume, you might do it both ways. It might be a disk problem, and you'll do it that way, and you'll do it the shell way, and just see if you get the same answer, and that'll be okay. All right, Zach, do you have a question?
I thought P went to the center of the strip.
No. Well, it does, but remember, how wide is the strip? Right? Because we've now turned it into integral, it's infinitely narrow. So it has no width to speak of, right? All right. So we put 2 pi, and then it's P times H, and then this integral we said goes from what to what? The strip fills the space from 1 to 4. Now type that into your calculator. And hopefully we get 328 pi over 15, which is the same exact volume we got earlier. All right? Now, once you get the hang of that, again, P is the one that people have trouble, for whatever reason, distinguishing. P is not the length of a strip. And now I said it, I think of it as right minus left, because when we subtract to get that distance, we always want bigger minus smaller. Okay, your strip here is top minus bottom, so it's top curve minus bottom curve. But on the strip, it always is like this. Okay, let me give you a couple quick ones here for you to try. Let's do this region. Y equals x squared plus 1. First quadrant. And x equals 1. So bounded in that fashion. And let's revolve it about Revolve at about x equals 2. Try that with, this would be another one that if we were going to do a washer, a disc washer, we'd have to split it into 2. So a shell works better on this one. What?
Wouldn't that make like a
Wouldn't it make a what?
since it's a parabola, there's no top on it. It opens up and there's no top.
It's the first quadrant. And you do below.
Oh, you do it.
Okay. Yeah, I guess I thought I was making it easier by saying first quadrant. I think a lot of times it would say this. Bounded by y equals x squared plus 1, bounded by x equals 0, bounded by y equals 0.
Yeah, I would do
So it's below the parabola.
just for some reason.
Yeah. Be below the parabola. Yeah. Okay, how we doing?
X squared plus 1.
Here.
3 by 6.
But it's on the X.
Yes, that is correct.
Okay, here's what I got so far. Okay, we're revolving about x equals 2, vertical axis of revolution. So since it's shell method, parallel to the axis of revolution, it'll wrap like this. Okay, so the integral is going to go from what to what?
0 to 1.
0 to 1. The strips fill the space from 0 to 1. That's still important. H is the height of the strip, so that's the y value here, x squared plus 1 minus 0. What's P?
2 minus x.
Okay, P is from the center to the strip. The strip is x. 2 subtract x. So P would be 2 subtract x. So we have the 2 pi out in front. P times h. There it is. And the answer was 23 pi over 6. Okay, last one. Last one right here. Now, again, that last one could have been with a washer, but it had been horizontal strips. It had empty space. You'd had to split it into two parts. Could have been done. Here's one that you might find easier to do with a washer, but I'm telling you, you have to use shell. Have to use shell method. And I think there's a couple on the homework where they say you have to use shell method. I might do that on the quiz. I might give one where you have to use a certain method. But there will be some where you just find the volume and you can choose if there's an option. Obviously, those ones we did yesterday, there's no option on those. But so this one, you have to do a shell method. Actually, I wouldn't need x equals 0 in there. I wouldn't need x equals 0 in that region. I'm looking at the region below the parabola. Okay, below the if you yeah. Well, no, it wasn't all that clear. Below the parabola.
Pretty clear with common sense.
Well. What direction is the strip? It's got to be horizontal, right? You're revolving around y equals 4, which is a horizontal line. So you have to have a horizontal wrapping, a horizontal strip.
It's so much easier if you misread y equals 4 x equals 4.
All right. Oops. What is H? What's H? No. What's H? 2 minus root y. The length of the strip is 2 minus root y. Because x is equal to, just same thing we've always done. What's P? What's P? 4 minus y. This strip would label y, as opposed to the other strips labeled that. Because this strip has got a y position. It's down here near 0 or 1 or 2 or 3. Could be all the way up here to y of 4. So the strip is labeled y. The distance from the center to the strip is this y coordinate, 4, minus its y coordinate, which is y. 4 minus y. And then the integral goes from 0 to 4. Because the strip would fill the space from 0 to 4. And then you get your answer. All right. LH, page 427. It's on your assignment sheet. It's the next line down on your assignment sheet. Again, you've got, I think there's 5 problems on there, maybe 4 or 5. 5 problems. The first 4 you have to use shell method. And I think on one of those you have to actually split it into 2 pieces and do it. But you have to. First 4, 4, 9, 12, 17, you do shell method. On 21, it's actually 4 parts. They give you a region and they revolve it around 4 different things. You have your choice. You can use disc, washer, you can use shell, whichever works better for each of the individual parts. And again, you can check up here, see if you're on the right track with your answer.
Is there anything else?
Okay. Remind me again tomorrow.
You said it's supposed to be back.